W sin alpha together resolving along the plane, we can write like this: P cos alpha in the rightward direction, W sin alpha in the leftward, and minus F because it is acting in the rightward direction. So, instead of F we can write mu r. Now, from equation number 1 and 2 combining together, I can write like this: P cos alpha is equal to W sin alpha minus mu into, instead of r I can write like this: W cos alpha plus P sin alpha. Now, taking P outside, so this minus mu P sin alpha I am bringing it to the left side. Similarly, taking P outside, I will get cos alpha plus mu sin alpha is equal to W taking common, W into sin alpha minus mu cos alpha. From this equation, P is equal to, bringing this cos alpha plus mu sin alpha as denominator, I can write like this. So, we also know that instead of mu I can write tan phi, which is sin phi by cos phi. Substituting, instead of mu sin phi by cos phi, I will get like this. This LCM cos phi in the numerator as well as in the denominator, it gets cancelled. Using the formula, this is W into sin of alpha minus phi, this is cos of alpha minus phi, this is sin by cos, that is tan alpha minus phi. This is P, that is the force required when the body is tending to move down. This is the force required to keep the body up the plane. So, suppose if the body is tending to move up, then the frictional force will be acting in the opposite direction. Then the formula becomes P is equal to W tan of alpha plus phi. Now, we will see the third case, as force is making an angle theta with the plane and the body is tending to move down. When the body is tending to move down, the frictional force is acting in the opposite direction like this. Now, for the equilibrium condition of the body, there are several forces acting on the body which I have shown like this. Suppose P is the force applied on the body. So, this can be resolved into two components, one is P cos theta and the vertical component is P sin theta. Similarly, the load can be resolved normal to the plane, that component is W cos alpha and the horizontal component is W sin alpha. The directions are also shown. Now, for resolving all the forces normal to the plane, R is vertically upwards is equal to the downward forces, that is W cos alpha minus P sin theta, because this is acting in the upward direction, therefore minus sign. And now resolving the forces along the plane, W sin alpha, that is in the leftward direction, is equal to, rightward we have this frictional force, that is mu r, plus P cos theta, that is the force applied on the body, that is a horizontal component. So, from equations number 1 and 2, I can write like this: W sin alpha is equal to, instead of r I can write this thing, W cos alpha minus P sin theta plus P cos theta. Now, bringing this mu P, mu W cos alpha left side, it becomes minus when it comes to left side, and W I have taken it outside. So, sin alpha minus mu cos alpha is equal to, taking P common now, P into cos theta minus mu sin theta. So, P is equal to, so bring cos theta minus mu sin theta as a denominator. So, now instead of mu I can write tan phi. Tan phi is nothing but sin phi by cos phi. Taking LCM, I can write like this. So, sin phi by cos phi, sin alpha into cos phi, that LCM term, minus cos alpha into this numerator term sin phi. Similarly, in the denominator, and here the LCM cos phi in the numerator and in the denominator gets cancelled. So, using the formula P is equal to, this term I can write it as sin alpha minus phi, and the denominator term I can write it as cos theta plus phi. So, this is the force required to pull the body, and when the body is tending to move down. Similarly, I can have the second case, the force is making an angle theta with the plane, and the body tends to move up the plane. When the body is moving up, the frictional force will be in the opposite direction, that is just opposite to this direction, in this direction. So now the formula becomes just the symbols, minus becomes plus and plus becomes minus. So this is the formula for this case. Now we shall solve a couple of examples for the inclined plane. The first example being a body of weight 735 Newton rests on rough inclined plane of an angle 30 degree with horizontal, and an angle of friction between the body and the plane is 15 degree. Find the horizontal force required to hold the body from sliding down the plane. First of all, let us draw the diagram for the problem. Now it is an inclined plane, the angle is 30 degree with the horizontal, a body is resting, and the body is sliding down, therefore the friction is opposite to the sliding down, therefore the direction of friction is very important. Now the various forces are acting on the body, that is normal force or normal reaction R, and because of the weight of the body which is perpendicular to the ground, it has two components, one is W cos 30, other one is W sin 30. Now weight of the body 735 Newton, a horizontal force that is P, that is 30 degree with the horizontal, this is the horizontal line, the angle is 30 degree. So this is the data given, that is alpha is 30 degree, W 735 Newton, phi is 15 degree, that is angle of friction. When you know phi, angle of friction, we can find out coefficient of friction, because we have the formula mu is equal to tan phi. From this, coefficient of friction is 0.268. Resolving all the forces horizontally for the equilibrium condition, horizontal forces, that is P cos 30 plus F, that is in the rightward direction, is equal to leftward direction forces are, this is W sin 30, W means 735 sin 30, that is equation number 1. Resolving the forces vertically, and we have upward force, that is R, is equal to downward force W cos 30 plus P sin 30, that is equation number 2. From both the equation 1 and 2 combining together, we can write like this, that is P cos 30 plus, instead of F I can write mu R, F is equal to mu R, mu into, instead of R I can write W cos 30 plus P sin 30, that is equal to W sin 30, that is 735 sin 30. So substituting the values like this, I will get P as 735 is common here, in bracket sin 30 is 0.5 and cos 30 0.866, and bringing this as a denominator and simplifying, I will get the answer as 196.98 Newton. We can also solve the same problem using the formula P is equal to W into tan alpha minus phi. So to remember the formula is very easy when it is coming down. Suppose if the body is going up the plane, we have to use the formula W tan alpha plus phi. Let us see the second example. A body of weight 500 Newton just pulled up a plane inclined at 30 degree to horizontal by a pull of 400 Newton, inclined at 25 degree with the plane. What is the coefficient of friction between the body and the plane? Let us draw the diagram first. A body of weight 500 Newton, it is resting on the inclined plane of an angle 30 degree, and a pulling force, that is P, is equal to 400 Newton, which is at 25 degree with the plane, that is horizontal plane. After drawing the diagram, for the equilibrium condition, let us resolve all the forces horizontally and vertically. So resolving the forces normal to the plane, that is R, which is acting upwards, which is equal to the addition of these two forces, that is W cos 30 and P sin 35. So that is W means 500 Newton cos 30 minus 400 sin 25, because both are acting in opposite directions, that is why the minus sign. Now resolving all the forces horizontal to the plane, that is P cos 25, that is 400 cos 25, which is acting in the rightward direction, is equal to the leftward direction forces are the frictional force F as well as 500 sin 30. So that is why F less 500 sin 30. So this direction of friction is very important because the body is pulled up the plane, therefore the frictional force is in the opposite direction. From both the equations combining together, 400 cos 25 is equal to, instead of F I can write mu R, that is mu into, instead of R I can substitute this, plus 500 sin 30. The value of this thing is 362.5 is equal to mu into, simplifying this I will get it as 264 plus 500 into 0.5, that is sin 30 value. 264 mu is equal to 362.5 minus this figure, that is 250. So mu is equal to, I will get it as 0.426, that is the coefficient of friction between the body and the plane is 0.426. We can also solve the problem using the formula straight away. P is equal to W into sin alpha plus phi divided by cos theta minus phi. In this formula we know all the values, P we know, W we know, theta we know and alpha we know. Only the value which is unknown is phi. We can find out phi from this formula. We know the formula tan phi is equal to mu, like that also we can solve the problem. Now let us solve the third problem. A body weighing 10 kilonewton is to be moved up an inclined plane of an angle 15 degree. Coefficient of friction between the body and plane is 0.3. If the effort is parallel to the plane, find the value of the effort. So let us draw the diagram first. A body weighing 10 kilonewton is resting on the inclined plane of an angle 15 degree. Coefficient of friction between the body and the plane is 0.3. Angle of inclination 15 degree. Okay, for the equilibrium condition, various forces are acting on the body. We can resolve like this. This weight of the body W can be resolved into two components, that is W cos 15 and W sin 15. Resolving vertical to the plane, the normal force R is equal to W cos 15. W is equal to 10 kilonewton, therefore we get the value R as 9.659 kilonewton. Resolving all the forces horizontal to the plane, P which is acting in the rightward direction, F the frictional force is acting in the leftward direction because the body is moving up, therefore frictional force is in the opposite direction. P minus F, both are in opposite directions, is equal to W sin 15. From this equation I can write P is equal to W sin 15 plus F. Instead of F I can write mu R, R value is 9.659, mu value 0.3. Substituting we will get the value P is equal to 5.488 kilonewton. We can also solve the problem using a formula directly. P is equal to W sin alpha plus phi divided by cos phi. This formula we have already seen, and in this all the values we know. W we know alpha, phi is given here. Phi we can find out using the formula phi is equal to tan inverse mu, like that we can find the phi. Substituting the values we get the P which is same as that of 5.488 kilonewton. So far students, we have discussed about what is friction, types of friction and the force required to move the body on a horizontal plane, on an inclined plane. Hope students you understood the topic friction. We meet again, till then goodbye.
Further clarification, contact the Additional Secretary, State Board of Technical Education and Training, 7th floor, BRKR Bhavan, Tank Bund Road, Hyderabad 500 063. Fax 040 322 054.